All right, strap in, everyone. We're going deep on the Qwen 2.5 technical report today.
Uh-huh.
If you're listening to this, you probably want to get a grip on these new large language models fast.
Yeah,
And we're here to cut through the jargon
absolutely.
and help you really get what makes this tech so groundbreaking.
It's really exciting stuff. And we're going straight to the source.
Right, to the source.
This report is straight from the Qwen team, the folks who actually built this thing.
It's not just one model, though, is it? It's like a whole family of models, each with its own specialty.
Exactly. They've got both dense models, which you can actually download and use yourself.
Okay.
And then they've got MOE models, that stands for Mixture of Experts,
Because of experts.
which are accessed through their API.
Oh, cool.
So it's like having a whole toolbox of language models at your disposal.
I like that. A toolbox. Okay. And they come in a variety of sizes, too, which is great for people who might not have access to the most powerful computers, right?
Yeah, exactly.
Yeah.
Qwen 2.5 has models with 3 billion parameters, 14 billion, and 32 billion. So you can actually get really impressive results without needing a supercomputer.
Awesome.
And then, of course, they also have the two MOE models, Qwen2.5-Turbo and Qwen2.5-Plus,
Right.
which are really tuned for specific tasks and offer this kind of balance between power and efficiency.
One thing that really jumped out at me was just the massive amount of data they use to train these models. We're talking trillions of data points.
Oh, yeah, data is the lifeblood of these LLMs.
Yeah.
And Qwen 2.5 has been trained on a massive 18 trillion tokens.
18 trillion.
That's more than double the data they used for Qwen 2.
Wow. So what does all that data actually mean for someone like me? More data equals better results.
Think of it this way. They've given the model a much larger library to learn from.
Okay.
This translates to a model that potentially has a deeper understanding of language, better coding skills, and even improved math abilities.
You had me at math abilities.
Right.
I'm terrible at math.
Right. But isn't there a risk, though, that with all that data, the model could learn the wrong things?
Yeah, that's what I was thinking. It's like, how do you make sure it doesn't pick up bad habits, you know?
That's where data quality comes in. It's not just about throwing any old data in there.
Right.
They actually use multidimensional analysis and filtering to make sure they're training the model on high-quality information.
So it's like a carefully curated diet for the model.
Exactly. They're feeding it the good stuff.
Okay, so they're being picky eaters, so to speak. But how do they make sure the models are learning the right stuff for specific tasks? Like, how do they specialize it?
Well, one of the cool things they did is they actually incorporated data from their specialized models, like Qwen 2.5 Math and Qwen 2.5 Coder, right into the pre-training.
Oh, interesting. So they're building on what they've already learned.
Right. It's like giving the model a head start in those areas.
I like that. A head start. Makes sense.
And they actually even use some of their previous models, like Qwen2.5-72b Instruct and Qwen2.5-72b Instruct, to create synthetic data,
Huh.
further enriching the training set.
So they're really like bootstrapping the whole process, huh?
They're using everything they've got.
Yeah.
And one of the things they've been very careful to do is to balance the types of data they're using, making sure the model has this well-rounded learning experience across different topics and styles.
It's like a balanced breakfast for the AI.
Exactly.
I like that analogy.
It needs all its nutrients.
Keeps it healthy.
Right.
This whole data-first approach is fascinating. It's not just about cramming as much information in as possible.
It's about being selective. You know,
Uh-huh.
It's all about quality over quantity.
Quality over quantity.
And that's what fuels the model's ability to understand and process really long chunks of text, which is something they call long context pre-training.
Okay, this long context thing sounds intriguing. How does it actually work?
So they use a two-phase approach. First, they train the model on shorter sequences of 4,096 tokens.
Okay.
Then, for the final stage, they crank it up to a whopping 32,768 tokens.
Wow, that's a lot of text. Does this mean it could even like make sense of those super long legal contracts I have to deal with? I mean, could it actually like get through all that legalese?
You're thinking along the right lines.
Okay.
This means that Qwen 2.5 can handle much longer and more complex pieces of text. So potentially, yeah, it could be a really powerful tool for analyzing those dense documents you mentioned.
That's incredible. But it's not just about words, right? I vaguely remember something about how Qwen 2.5 can understand other forms of data too, like beyond just plain text.
That's where it gets even more interesting. Qwen 2.5 can also understand structured data, like tables and JSON.
Wait, so it can analyze a spreadsheet. That's a game changer for my work. Seriously.
It opens up a ton of possibilities.
Wow.
Imagine being able to just ask a language model to pull specific insights from your data or generate reports based on like complex spreadsheets, all without writing a single line of code.
Okay, now that's impressive. And speaking of impressive, this report goes into a lot of detail about how they fine-tune Qwen 2.5 for specific tasks, like after that initial pre-training.
Right, post-training.
Yeah.
The post-training phase is where Qwen 2.5 really shines.
Okay.
This is where they take all that raw power and potential from the pre-training
Yeah.
and really shape it into a tool that can be used for specific jobs.
So let's talk about those specific areas. What are we talking about here? I'm particularly interested in long sequence generation. I mean, that's something that's always fascinated me.
That's a big one. Qwen 2.5 can actually generate text sequences up to 8,192 tokens long,
Wow.
which is way beyond what most language models can handle.
That's like writing a whole short story. I'm guessing they had to come up with some pretty clever ways to train for that.
Yeah, they really had to push the boundaries. They created specialized data sets designed specifically to push the model's limits when it comes to generating longer pieces of text.
So thinking bigger and broader.
Right.
Yeah.
Longer, more complex, more nuanced.
Yep.
Imagine the possibilities there. From summarizing really lengthy reports to crafting really creative content.
Starting to sound like a super powered LLM. I mean, is there anything this thing can't do?
It's really pushing the limits, that's for sure. And it's not just about generating, creative text.
Right.
They've also made some serious strides in making Qwen 2.5 a better math whiz.
Hold on, math. So it's not just a wordsmith, it can crunch numbers too. I mean, I'm impressed already, but now it's doing math.
You got it. They've actually used a technique called chain of thought data, which essentially teaches Qwen 2.5 to solve math problems step by step, just like a human would.
It's thinking like a mathematician.
It's really trying to model that human thought process.
That's pretty wild. So it's not just about, crunching numbers. It's about actually understanding the logic behind them.
Exactly. They've really focused on developing the model's ability to reason, not just calculate.
Okay, I'm starting to feel a little inadequate here.
Don't worry, we all are.
All right, what about coding? Could this thing help me, write some code for my next project? I'm always looking for a shortcut.
It's getting there. They included data from Qwen 2.5 Coder in the training process,
Okay.
which is a model specifically designed for programming.
So it's had some coding lessons.
It's been to coding boot camp.
Nice.
This means Qwen 2.5 has been exposed to nearly 40 different programming languages.
Wait, 40? Seriously, 40 programming languages. That's incredible.
It's pretty remarkable.
But how do they know the code it generates actually works? Is it actually any good?
That's a great question. They use something called a multilingual sandbox to actually test the code
Oh, that's cool.
and make sure it's actually doing what it's supposed to do.
It's like a virtual playground for code.
Exactly.
That's really neat. Okay, so it sounds like they're really serious about making Qwen 2.5 a reliable tool for programmers.
They are. They've also put a lot of effort into making Qwen 2.5 more consistent as an instruction follower.
Like it actually listens to what you tell it to do.
Yeah, think of it like teaching it to follow directions reliably.
Oh.
They added hundreds of general system prompts to the training data.
So it's learning the rules of the road, so to speak.
Exactly, to make sure it understands and responds to instructions in a more predictable way.
Okay, that makes sense. If you're going to use these models in the real world, you need to be able to trust that they'll do what you ask them to do.
Absolutely. You need that reliability. And that brings us to one of the most fascinating parts of this whole project, reinforcement learning.
Okay, I've heard a lot of buzz about reinforcement learning. Is this where it gets really interesting?
Things are about to get really interesting. They've actually used two types of reinforcement learning, or RL for short,
All right.
to fine-tune the model. There's offline RL, which helps Qwen 2.5 learn more complex skills, like reasoning and problem solving.
So it's like giving it a challenge and letting it figure things out on its own.
You got it. It's like sink or swim.
Trial by fire.
Right.
Okay, and then there's online RL. What's the difference?
So online RL is all about making sure that Qwen 2.5 generates text that actually aligns with human preferences.
Oh, so it's learning to be more human-like in its responses.
Exactly. They want to make sure the model is truthful, helpful, concise, relevant, harmless, and free from bias.
That's a tall order. I mean, how do they even begin to train for all that?
It's a massive undertaking. They've used just a ton of data, and a very specific set of criteria to achieve this.
So they're really trying to instill some values in this model.
They're trying to make sure it's a force for good.
It sounds like a massive undertaking.
Yeah.
But it's so important if we're going to trust these models to generate content we can actually use. I mean, content that's not going to lead us astray.
It's absolutely essential.
Speaking of getting it right, how did Qwen 2.5 actually stack up against the competition in their benchmarks? Like, how does it measure up? Did they do those kinds of comparisons?
The report is packed with performance comparisons, and there's some really impressive wins. For example, their 72 billion parameter instruct model actually rivals the performance of the much larger Llama 3405B instruct model in a lot of tasks.
Wow, so it's going toe-to-toe with the big players.
It's definitely a contender, and the Qwen2.5-Turbo model is incredibly efficient for its size.
Okay.
Which is great for folks who might not have access to a ton of computing power.
They're really trying to make this technology more accessible. It's great to see. But I'm guessing this is just the beginning, right? There's more to come. I mean, where do they go from here?
The Qwen team is very clear that they're just getting started.
Oh, wow.
They're already working on incorporating even more data, exploring ways to include other types of data like images and sounds.
Oh, it's multimodal?
Multimodal, exactly. And then pushing the boundaries of what these models can do when it comes to reasoning and problem solving.
Yeah.
There's just so much more that they want to explore.
That's so exciting. It really makes you wonder, if Qwen 2.5 is this capable now, what will future versions be able to do? It feels like we're just scratching the surface here.
It's mind-blowing, isn't it? And it's not just about what they will be able to do.
Right.
It's about what we will be able to do with these incredible tools.
What problems will we be able to solve? What new possibilities will we unlock? I mean, it really does feel like a whole new world is opening up.
The possibilities are pretty much endless.
All this talk about data and training leads us to how they actually make sure this model can handle these massive amounts of text. I mean, we're talking about feeding it entire novels, right? Let's talk about that next.
Let's do it. It really makes you think about the future, right?
Oh, absolutely. But for now, let's maybe zoom back in on the technical details a bit.
Okay.
How did they actually make this model work? We're just talking about how Qwen 2.5 can handle these incredibly long pieces of text.
Right.
But how does that actually happen? It feels almost magical.
It's remarkable, isn't it? And remember that long context pre-training we were talking about? Well, they use this two-phase approach. They initially train on shorter sequences of 4,096 tokens, then extend the context length to 32,768 tokens for the final stage, except, of course, for Qwen 2.5-Turbo, which uses a progressive expansion strategy, and they gradually increase the context length during pre-training to a whopping 262,144 tokens.
250,000 tokens? That's insane. That's like feeding an entire novel into the model at once.
It's a lot of text.
It is. But how does the model actually keep track of the order of words in these super long sequences? It seems like it would be so easy to lose the thread, so to speak.
Right.
Like, how does it not get lost in the weeds?
That's where a really clever technique called ROPE comes in. It stands for Rotary Positional Embeddings.
ROPE, okay.
Think of it like giving each word a numbered ticket.
Okay.
So the model knows its place in line, even when the line is incredibly long. This really helps the model keep everything straight and understand the flow of the text.
So even with like 1,000,000 words, Qwen 2.5 doesn't lose its place.
Nope. And they've actually increased the base frequency of ROPE to help it handle these super long sequences even more effectively.
That's wild. Okay, but even with all that training, isn't there still a limit to how much text the model can actually handle at once when it's actually being used?
You're right. There are practical limits.
Yeah.
And that's where techniques like YARN and DCA come in. YARN stands for Yet Another Rope Extrapolation Method.
Catchy.
And then DCA stands for Dual Chunk Attention.
Okay, I'm trying to keep up.
These are specialized techniques that allow the model to kind of break down those megalong texts into smaller, more manageable chunks during the analysis phase.
So it's like they're giving the model a strategy for tackling these like massive documents.
Exactly.
Instead of trying to swallow the whole thing at once, it can kind of like break it down into bite-sized pieces.
That's a great way to put it. And it's incredibly effective. So, for example, Qwen 2.5-Turbo can handle up to 1,000,000 tokens.
Wow.
While other models in this series can process up to 131,072 tokens.
I'm just like blown away by the scale of this. And I bet those techniques are particularly helpful when dealing with those complex legal documents we talked about earlier, right?
Absolutely. Imagine being able to analyze just a mountain of legal text or like a massive code base, all with a single prompt.
That would make my life so much easier.
It's the power of these long context LLMs.
All this power comes from all that, like careful attention they paid to both pre-training and post-training, right? It's like building a foundation and then adding all the bells and whistles.
You got it. Post-training is where they really fine-tune the model for those specific tasks.
Right.
And they really went above and beyond with Qwen2.5.
In what way?
Well, one of the key improvements was just the sheer volume of data they used for supervised fine-tuning. We're talking millions of examples.
Millions.
They really spared no expense.
Wow, they really went all out. So what are some of the specific areas they focused on during this like post-training phase? What were they trying to like really dial in?
They really focused on areas where previous models have struggled. Long sequence generation was obviously a big one, as we discussed earlier.
Yeah.
But they also focused on things like math problem solving, coding, understanding instructions, making sense of structured data, logical reasoning, cross-lingual transfer, and handling system instructions more robustly.
They really did try to cover all the bases, huh?
It was a comprehensive approach.
It's like they wanted to make sure Qwen 2.5 could excel in just about any task you could throw at it.
Precisely. And they were super meticulous about it.
Okay, give me an example. Like, how did they approach long sequence generation, for instance?
All right, so for long sequence generation, they developed these specialized data sets that were specifically designed for long responses. And they used some cool techniques like back translation to generate queries for long text data. And then they even used Qwen2 to filter out low-quality data.
That's smart.
So it's a multi-step process to
Yeah.
make sure they're training on the best possible information.
Like they're creating a masterclass in long-form writing for the model. Okay, what about the math improvements? We were talking about how they're using that, chain of thought data to teach Qwen 2.5 to think like a human mathematician. Like, how did they actually put that into practice?
So remember you were saying how you learn best by breaking down complex problems into smaller steps?
Yeah, I'm a big fan of baby steps.
Well, that's exactly what they're doing here.
Okay.
They've compiled chain of thought data from all sorts of sources. Public data sets, textbook problems, even problems generated by the model itself.
It's like giving the model its own personal tutor, walking it through each step.
It's all about guiding it through that problem-solving process.
But how do they actually make sure that the model is actually like reasoning correctly and not just stumbling on the right answer by chance? You know, how do they know it's not just getting lucky?
That's a great question. And that's where techniques like rejection sampling and reward modeling come in.
Okay.
They help ensure that the model is actually understanding the underlying logic and not just, getting lucky.
So it's not just about getting the right answer. It's about understanding like the why behind it.
It's about learning how to think like a mathematician.
That's incredible. Okay, what about the coding improvements? How did they like level up Qwen 2.5's programming skills?
So they incorporated the instruction tuning data from Qwen2.5 Coder.
Right, their specialized coding model.
Exactly. And that model has been trained on just a massive amount of code in almost 40 different programming languages.
I'm still stuck on that 40 programming languages thing. That's crazy. But coding is more than just, writing lines of code.
Right.
It's about understanding the logic, the structure, the big picture, So how do they make sure that the code that Qwen 2.5 generates is actually functional and doesn't just look good on paper?
So they actually created this multilingual sandbox to test the code that Qwen 2.5 generates.
Oh, that's cool. So they can actually run the code and see if it works.
Exactly. They make sure it actually works as intended in different programming environments.
So they're not just taking the model's word for it.
They're verifying it.
It's like a little virtual testing ground for code.
Precisely. And they also use a technique called code-based validation to make sure the model's really understanding and following instructions.
Oh, tell me more about that.
They actually use LLMs to generate instructions.
Okay.
And then the corresponding code needed to verify those instructions.
Oh, that's clever.
So it's like this built-in quality control system.
Yeah.
Making sure that the model's producing meaningful output.
So it's like teaching the model to be accountable for its work.
Exactly.
And speaking of accountability, they've really put a lot of emphasis on using reinforcement learning to align the model with human preferences, right?
Right. Reinforcement learning is just a key part of this whole process.
Yeah.
And as we mentioned earlier, they've used two types. Offline RL, which helps with complex tasks like reasoning.
Right.
And then online RL, which is all about making sure that the model generates text that we humans actually find useful and appropriate.
It's like the model's finishing school, where it learns the nuances of human communication.
Exactly. They've trained Qwen 2.5 to generate text that is truthful, helpful, concise, relevant, harmless, and free from bias.
Those are some pretty high standards.
High standards, but absolutely necessary.
Yeah, especially when we're talking about using these models in real-world scenarios, right? Where trust and reliability are so important.
Trust and reliability are paramount.
It's clear that they've really gone to great lengths to make sure that Qwen 2.5 is not just a powerful language model,
Right.
but a responsible one.
Responsible AI is a huge priority.
Yeah, and it's reassuring to see that kind of foresight.
It's essential.
Okay, but let's get back to the technical nitty-gritty for a moment. They've done a lot of work to actually evaluate the performance of Qwen 2.5, right?
Oh, yeah.
I mean, they want to make sure it can actually deliver on all its promises.
They've really put Qwen 2.5 through its paces,
Good.
using this wide range of benchmarks, both open source and in-house.
Did they compare Qwen 2.5 to other, leading language models? I'm curious to see how it stacks up against the competition.
They did. And the results are very impressive.
Okay, spill the tea. Give me the highlights.
So Qwen 2.5 actually performed exceptionally well, often exceeding the performance of much larger models.
Really? Okay, can you give me some concrete examples?
Yeah. For example, the Qwen 2.5 72B model achieved results comparable to the much larger Llama 3405B model.
So it's like what, a David versus Goliath kind of situation?
It's a classic underdog story.
I love it.
And it's not just about performance, it's also about efficiency, right?
Yeah.
Because Qwen 2.5 is much smaller, it requires significantly less computational power, which has implications for both cost and the environment.
So it's a win-win, like better performance and more sustainable.
You got it. And that's one of the things that makes this work so exciting.
Yeah.
It's not just about pushing the limits of what's possible, it's also about making those possibilities more accessible to a wider community.
I love that. They're democratizing access to this powerful technology.
Exactly.
Okay, so we've talked about the big picture, the high level stuff, but I'm really curious about the specifics. How did Qwen 2.5 actually perform on those different benchmarks?
All right, so let's dive into the numbers.
Let's do it.
So they saw similar impressive results with other models in the series. For example, the Qwen 2.5 14B model outperformed many larger models on benchmarks like MMLU and BBH.
Okay.
And then Qwen 2.5-Turbo really shines when it comes to efficiency, especially on the MMLU Pro benchmark.
They really seem to have struck a nice balance between performance and efficiency across the entire model family.
They did. It's like they have a tool for every job, regardless of your computing power.
That's awesome. But they didn't just rely on existing benchmarks, right?
They didn't. They actually developed their own in-house data sets as well.
Why did they do that? I mean, weren't there enough benchmarks already out there?
Well, they felt that the existing open benchmarks didn't fully capture all the nuances of these really advanced LLMs.
That makes sense. They needed a way to really measure what these models could do.
Exactly. They wanted to create data sets that would specifically target areas where these models excel, like knowledge understanding, text generation, coding, and more. And importantly, they did these evaluations in both English and Chinese, demonstrating the model's multilingual capabilities.
So they were really thorough.
Incredibly thorough.
It's like they created this custom-designed obstacle course to really put the models through their paces to see what they're truly capable of.
That's a great way to think about it. And they also took a close look at their reward model.
Right, the reward watch.
Which is the part of the system that guides the reinforcement learning process. And they benchmarked their reward model against other leading models. And it performed exceptionally well, especially on benchmarks like PPE and their own in-house Chinese human preference benchmark.
So they're confident that the reward model is providing the right kind of feedback to help the model learn and improve.
It's like they have a winning formula for training these LLMs.
They've really thought of everything.
They have. They also tested Qwen 2.5's long context capabilities extensively, using benchmarks like Ruler, LV-Evil, and Long Bench Chat.
Okay.
And the results are really promising.
Good.
They demonstrate that Qwen 2.5 can actually understand and process long and complex pieces of text effectively.
So it can handle those million-word documents we were talking about earlier.
It can. And not only that, they've actually introduced a sparse attention mechanism specifically to enhance the inference speed, which is particularly important when dealing with long contexts.
So it's not just about being smart, it's about being fast, too.
Exactly.
Yeah.
Because who wants to wait around for a slow model to churn through a mountain of text? This sparse attention approach can actually reduce the computational burden of the attention mechanism.
So it's like they're optimizing for both performance and efficiency.
They're optimizing for everything.
It sounds like they've really covered all their bases with this release.
They've been incredibly thorough. Qwen 2.5 is a major leap forward in the development of large language models. It's powerful, versatile, and meticulously engineered. And it's not just about pushing the boundaries of what's possible, it's also about making those possibilities accessible to a wider audience.
It's inspiring to see this kind of progress. If this is where we are now, I mean, it really makes you wonder what the future holds for large language models. What new breakthroughs are just around the corner?
That's the big question, isn't it? But based on what we've seen here, I'm incredibly optimistic about the future of this technology.
Me too.
Qwen 2.5 is a testament to human ingenuity and our ability to create these really powerful tools that can potentially benefit society in just countless ways.
It really is mind-blowing to think about all the possibilities, isn't it?
It is. And it's not just about the technology itself, it's about how we choose to use it.
That's a good point.
It's about making sure that we use these powerful tools wisely and ethically. And I think, by working together, we can really harness the power of large language models to create a better future for everyone.
Okay, so we've talked a lot about the model's capabilities, its performance, all the technical nuts and bolts. But now I'm curious to hear about how it actually stacks up against the competition. Let's dive into those evaluation results next and really see how Qwen 2.5 performs when put to the test.
All right, let's do it.
All right, time to get down to brass tacks. Let's
Yeah.
talk about those evaluation results. We've heard a lot about what Qwen 2.5 can do, but how does it actually perform in the real world?
They used a really comprehensive suite of benchmarks, both open source and in-house, to assess Qwen 2.5's capabilities.
Okay.
And one thing I really appreciate is that they were super careful to avoid any data leakage during the evaluations.
What does that mean, data leakage?
So basically, they used techniques like anagram matching to make sure that the model wasn't getting any unfair advantages by seeing data it had already encountered during training.
So it's like making sure the student hasn't peeked at the answers before the test.
Exactly. It's a real test of the model's abilities, not just a way to make it look good.
I like that. Rigorous testing.
Yeah.
So these evaluations, they cover a wide range of tasks, right?
Oh, yeah. From understanding basic language to solving complex problems.
Okay.
And even reasoning like a human.
So the full spectrum of cognitive skills.
Pretty much.
All right, let's start with the base models, the ones that haven't gone through all that fine-tuning yet. I'm curious to see how they perform right out of the box, so to speak.
So for the base models, they evaluated them on a variety of tasks, including natural language understanding, general question answering, coding, mathematics, scientific knowledge, reasoning, and even multilingual capabilities.
Wow, that's a lot. What kind of benchmarks did they use to actually assess all these different skills?
They use a whole bunch of industry standard benchmarks. Things like MMLU, BBH, ARCC, Truthful QA. There's Winogrand, HelloSwag, GPQA, Theorem QA, even things like GSM8K, Math, Human Eval, MBPP, Multi-PLE, and then a whole range of multilingual tasks covering things like exams, understanding, mathematics, and translation.
Okay, stop. My head is spinning. That's a lot of benchmarks. So how did Qwen 2.5 do? Did it live up to the hype?
Okay, so the Qwen 2.5 base models actually outperform many other leading open weight models, often exceeding the capabilities of models that are significantly larger than themselves.
Really? Okay, so bigger isn't always better, it seems.
In this case, not necessarily.
All right, give me an example.
Okay, so for instance, the Qwen 2.5-72B model, it actually achieved results that were comparable to the much larger Llama 3 405B model.
Wow, so it's basically achieving similar performance, but with a fraction of the computational resources.
Exactly.
Okay, that's huge, especially for people who might not have access to massive computing power.
Exactly. It makes this level of performance much more accessible and cost-effective.
Yeah.
And it's not just the 72B model. Other models in the series, they showed similar impressive results. For example, the Qwen 2.5-14B model. It outperformed larger models on tasks like MMLU and BBH.
Okay.
And then Qwen 2.5-Turbo, that one achieved remarkably good performance for its size, especially on the MMLU Pro benchmark.
So they really seem to have hit a sweet spot in terms of balancing performance and efficiency.
They did. It's all about making these powerful capabilities more sustainable and accessible to a wider community.
Okay, now let's talk about the instruction tune models. The ones that have gone through that extra level of training to really align them with human preferences and specific tasks. I mean, these are the models that are going to be interacting with users out in the real world, right?
That's right. And for these evaluations, they actually used a combination of open benchmarks and in-house data sets.
Okay, so tell me, what kind of tasks did they really focus on during this stage of the evaluation? What were they looking for?
They honed in on areas like following instructions, understanding knowledge, generating different kinds of text, coding, and reasoning. And they tested these capabilities in English and Chinese, as well as multilingual settings. Really, they took a truly global approach.
So they really wanted to make sure these models could perform well across different languages and cultures.
Absolutely.
Okay, and drum roll, please.
What were they?
There were the results.
The results were really impressive. The instruction-tuned Qwen 2.5 models, they consistently performed really well, often matching or even exceeding the performance of much larger models.
Okay, give me some specifics. Which models really stood out?
All right, so the Qwen 2.5 17B Instruct model, for instance, performed exceptionally well on benchmarks like MMOU Redux, Math, MBPP, MultiPLE, Live Code Bench, Arena Hard, and MT Bench. And in many cases, it actually outperformed the much larger Llama 3.1-405B Instruct model.
Wow, again with the David versus Goliath victories. That's amazing. What about the smaller models in the Qwen 2.5 series? How did they hold up?
Okay, so for example, the Qwen 2.5-32B Instruct model outperformed most other models of similar size, including GPT-4 Mini on several benchmarks. And even the smaller models, like Qwen 2.57B Instruct and Qwen 2.53B Instruct, showed significant improvements over their predecessors.
So efficiency is really the name of the game here, huh?
It's a major theme.
They're getting amazing performance from these smaller models, which is just so exciting because it makes this technology more accessible, more usable, and more relevant for a wider range of people applications.
Exactly. It's about democratizing access to these powerful tools.
You mentioned that they also develop their own in-house datasets for these evaluations. Why go to the trouble of creating their own datasets when there are so many open benchmarks already out there?
Well, they felt that the existing open benchmarks didn't fully capture some of the nuances of these advanced LLMs. They really wanted to create datasets that would specifically target areas where these models excel. So things like knowledge understanding, text generation, coding, and more.
It's like they created a custom-designed testing ground.
Exactly. And importantly, they conducted these evaluations in both English and Chinese to get a more comprehensive picture of the model's capabilities.
It's like they were really trying to put these models through their paces, to see what they were truly capable of.
They didn't cut any corners.
They also evaluated their reward model, right? The part of the system that guides the reinforcement learning process.
Right. And they actually found that their reward model performed extremely well when compared to other leading models, particularly on benchmarks like PPE and their own in-house Chinese human preference benchmark, which basically just gives them more confidence that their reward model is doing a good job of guiding the language models toward generating high-quality, human-aligned output.
It's like having a top-notch coach who really knows how to bring out the best in their athletes. Okay, so we've talked a lot about Qwen 2.5 today. We've covered its massive training data, those innovative training techniques, and its impressive performance on all those benchmarks. What are your final thoughts?
I'm just really blown away by what the Qwen team has accomplished with Qwen 2.5.
Yeah, it's really impressive.
They've made significant strides in pre-training, post-training, and evaluation. And it's clear to me that they have a really deep understanding of all the challenges involved in developing these large language models, and they've come up with some truly innovative solutions.
They've really thought this through from start to finish, haven't they?
It's not just brute force. It's about intelligent design and careful optimization.
And the best part is they're achieving state-of-the-art results while also making these advanced capabilities more accessible, more efficient, and even, more environmentally friendly.
Exactly. It's inspiring work, no doubt.
Absolutely. So if this is where we are now, it really makes you wonder what the future holds for large language models.
It really does.
What new breakthroughs are just around the corner? It's exciting to think about.
It's impossible to say for sure what the future holds. But based on what we've seen here, I'm incredibly optimistic about the future of this technology. Qwen 2.5 is a testament to human ingenuity and our ability to create powerful tools that can potentially benefit society in countless ways.
And it's not just about the technology itself, it's about how we choose to use it. That's the really important part.
Absolutely. We have this responsibility to use these tools wisely and ethically. And I believe that, by working together, we can really harness the power of large language models to create a better future for everyone.
It's an exciting time to be following this field, and for all of you listening out there, we encourage you to think about what Qwen 2.5 could mean for you. What challenges could it help you solve? What new opportunities might it unlock? The future of this technology is, in many ways, up to us.
I couldn't agree more.
Thanks for joining me on this deep dive. Until next time, keep exploring.